This is lesson 6-1, the polygon angle sum theorems. Let's first start by defining what a polygon is. A polygon is a closed figure consisting of line segments. Okay, so a polygon is a closed figure. That means the beginning and the end need to meet, consisting of line segments. So the fewest number of sides that a polygon can have would be 3 sides, because if it had 2 sides, they wouldn't meet. So we already have studied triangles. We know that a polygon with 3 sides is a triangle. A polygon that is the union of 4 sides. And if you want, you can pause the video and see if you can fill in any of these on your own without looking at the notes. But if you can't, that's okay too. So a polygon that is the union of 4 sides we call a quadrilateral. Okay, in this chapter we're going to be studying quadrilaterals, specifically parallelograms, rhombuses, rectangles, and such. Polygon with 5 sides is a pentagon. A polygon with 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon, like an octopus has 8 legs. 9 sides is a nonagon. And 10 sides is a decagon. Okay, so these are some terms that you should be familiar with in case they're asked in a question. A regular polygon, now that's an important thing to know. A regular polygon is a polygon where all the sides and angles are congruent to each other. So a regular polygon, all sides and angles are congruent to each other. So if I'm talking about a regular quadrilateral and I want all sides and angles to be congruent to each other, that would be a square. A pentagon, a regular pentagon, all 5 sides are congruent, all 5 angles are congruent. So that's a regular polygon. All sides and angles are congruent. Now we're going to figure out what the sum of the interior angles of a polygon are and the exterior angles. We'll start with the interior angles. So this is a formula that you're going to need to memorize. The sum of the degree measure of the interior angles of a polygon, so those are the angles inside of the polygon, is 180 parentheses n minus 2. So this formula you need to memorize. It's the sum of the interior angles of a polygon, and sum meaning all of them together. N represents the number of sides. So if it's a triangle and it has 3 sides, I'm just substituting in 3 for n. If it's a quadrilateral and it has 4 sides, I'm substituting in 4. So let's do an example. Let's find the sum of the interior angles of a pentagon. So the pentagon I'll do with you, and then you try and do the 7-sided figure and come up with the answer and show it to me tomorrow. But a pentagon, look up above if you need to. A pentagon has 5 sides, so you first start by writing the formula 180 parentheses n minus 2. So write that down. 180, right here, 180 parentheses n minus 2. Now a pentagon has 5 sides, so I'm going to substitute in 5 for n. So I'm just going to rewrite that. 180 parentheses 5 minus 2. 180 times 3, because 5 minus 2 is 3. And 180 times 3 is 540. So the sum of the interior angles of a pentagon is 540. Now remember, that's all of the interior angles. If I wanted to just find one angle, I'd have to divide by 5. But that only works if it's a regular pentagon, so they have to use the word regular in there because that would mean that all the angles were congruent to each other. So you try and do a 7-sided figure. You can pause the video, do the 7-sided figure, write the formula 180 n minus 2, 180 7 minus 2, and then figure that out. You can of course use a calculator. So that's the interior angles of a polygon. The sum of the exterior angles of a polygon is even easier because there's no formula. The answer is just 360. The sum, again it's the sum, of the degree measures of the exterior angles of any polygon is 360. So it really doesn't matter if that polygon is a triangle, and I'm showing you an example of a triangle right here. The interior angles are 100, 30, and 50, because we know the interior angles add up to 180. And I'm showing you each of these exterior angles. If the interior angle is 100, the exterior angle is 80. The interior angle is 30, the exterior angle right here is 150 because they're a linear pair. This interior angle is 50, so this exterior angle is 130. And if I add it up, 80 plus 150 plus 130, I get 360. Now I'm going to do the same thing for a quadrilateral. So the interior angles are in black right here. Those all add up to 360. A quadrilateral, the interior angles is 360, and I find each of these exterior angles in red, because remember they're supplementary, and if I add up 115 plus 75 plus 99 plus 71 is 360. The quadrilateral is actually the only figure where the interior angles, the sum of the interior angles and the sum of the exterior angles is the same, 360 for both. So exterior angles there's no formula. You just have to memorize any polygon. The exterior angles will be 360, whether it has 3 sides, 4 sides, 8 sides, 10 sides. The exterior angles will be 360. Then we just have two definitions. Convex. If I have a convex figure, each interior angle is less than 180 degrees. So that's convex. Each interior angle is less than 180 degrees. So each of these figures up here is convex. All of these interior angles are less than 180 degrees. And the last word for today is concave. So a concave, at least one interior angle is greater than 180. So at least one interior angle is greater than 180. And I can see right here, angle C, this angle is greater than 180 degrees. So that's called a concave figure. Concave. At least one interior angle is greater than 180. Okay, so at this point you guys have a summary for chapter 6. So please look at the 6-1 summary and fill in the answers to the questions that I ask you, and write down any questions that you might have that you want to ask tomorrow. And then you also have to sum it up to fill in. And that's it for today.